In this question, you have to find the value of x and y which satisfied our equation. So without wasting time, let's simplify our equation. In numerator of the first term, we will open the first bracket. So we will get x plus xi. Your minus 2i will be as it is. And in denominator, we have 3 plus I. So to simplify this term, you have to multiply and divide by its conjugate, which is 3 minus I. Same thing we will do in the second term. Let's open the bracket. So we will get 2y minus 3yi plus I will be remain as it is. And the denominator we have 3 minus I. So to simplify this, we have to multiply and divide by its conjugate, which is 3 plus I. And on right hand side, we have I. Now let's multiply one by one. Your x multiply with 3 will give us 3x. Then x multiply with I will give us minus xi. Now it's time to multiply xi with 3 will give us 3xi. And xi into minus I will give us minus xi square. Now minus 2i into 3 will give us minus 6i. And minus 2i into minus I will give us 2y square. And in denominator we have a plus b into a minus b, which will give us 9 plus 1, or we can say 10. Similarly, now let's simplify the second term. 2y multiplied with 3 will give us 6y. And 2y into plus I will give us 2yi. Now minus 3yi into 3 will give us minus 9yi. And minus 3yi into I will give us minus 3yi square. Finally, your I multiplied with 3 will give us 3i. And I into I will give us I square. And in denominator, we have same thing. 3 minus I and 3 plus I will give us 10. And on right hand side, we have only I. So we have same denominator. We can add our numerators. So let's collect all the real terms. Your first real term is 3x. Then minus xi square will become plus x. And this 2y square will become minus 2. Similarly, the real part of the second terms are 6y. Then minus 3yi square will become plus 3y. And your I square is minus 1. Now let's collect the imaginary part. In first term we have minus xi and plus 3xi, which will become 2xi. And we have minus 6i. Now from the second term, we will get 2yi minus 9yi will become minus 7yi. And we have 3i. So let's write down plus 3i. And on right hand side, if we move over 10, we will get 10i. In further simplification, we will get this 3x plus x will become 4x. And your 6y and 3y will become 9y. And minus 2 minus 1 will become minus 3. Plus, if we take I common, we will get this 2x, then minus 7y, and minus 6 and plus 3 will become minus 3. And on right hand side, we have 0 plus 10i. Now, in our next step, let's compare real part on the both sides. The real part of the left hand side is 4x plus 9y is equal to 3. And on right hand side, we have 0. which will give us 4x plus 9y is equal to 3. Let's call it equation number 1. Now, if we compare imaginary part on both the sides, in left hand side we have 2x minus 7y minus 3, and on right hand side we have 10. So here we'll get 2x minus 7y is equal to 13. Let's call it equation number 2. Now, to solve this two equation, we have to multiply 2 with the second equation and add into the first equation. So we will get 2x 2s are 4x. Similarly, minus 7y into 2 will give us minus 14y, and 13 2s are 26. Now let's change the sign. So your 4x will cancel out, 9y plus 14y, 23y, and 3 minus 26 will give us minus 23. So your y must be minus 1. Now let's substitute the value of y in second equation. So we will get 2x minus 7y, or we can say minus 7 into minus 1 is equal to 13. So this minus minus become plus, and we will get 2x is equal to 13 minus 7, or we can say your x must be 3. So we get the value of x as 3 and y as minus 1, which is given in option B. Ta-da! In this question, we have to find the value of x which satisfies the condition of 1 plus I upon 1 minus I raised to x is equal to 1. Now, to simplify our complex number, we have to multiply and divide by conjugate of the denominator, which is 1 plus I. So, in numerator, we will get 1 plus I, the whole square, or we can say 1 square plus 2 into 1 into I plus I square. And in denominator, we have a minus b and a plus b, which will give us a square minus I square whole raised to x is equal to 1. Now, we know that your I square is minus 1. So this I square and 1 will cancel out, and in numerator, we will get 2y. In denominator, we have 2. So, we can say we have I raised to x is equal to 1. Now, we know that the value of 1 is actually I raised to 4n. If we compare the powers, we will get x is equal to 4n, which is given in option B. Ta-da! In this question, you have to find value of I raised to n plus I raised to n plus 1 plus I raised to n plus 2 plus I raised to n plus 3, where n belongs to natural number. So for simplification, if we take I raised to n common, we will get 1 from the first term. In second term, remaining term will be I. In third term, we will get I square. And in last term, I cube. Now, your first and second term will be as it is. We know that your I square is simply minus 1. So let's substitute minus 1. And the value of I cube is minus I. So let's write down minus I over here. So here 1 and minus 1 will cancel out, and I and minus I will cancel out. So your complex number is simply 0, which is given in option A. Ta-da! Here it is given that your f of z is 7 minus z upon 1 minus z square, where z is equal to 1 plus 2y. Then we have to find mode of fz. So first of all, let's write down our f of z. where your z is 1 plus 2y. So let's get z square, which will be whole square of 1 plus 2y, or we can say 1 square plus 2 times 1 into 2y plus 2y the whole square, or we can say 1 plus 4i plus 4i square. Now we know that your I square will be minus 1, so this 1 and minus 4 will become minus 3 and 4i will be remain as it is. So let's substitute the value of z and z square. In numerator we will get 7 minus z, or we can say minus 1 and minus 2y. And in denominator we will get 1 minus z square. So we will get plus 3 and minus 4i. Now let's simplify. 7 and minus 1 will become 6 and minus 2i will be as it is. And in denominator 3 plus 1 will become 4 and minus 4i will be as it is. Now if we take 2 common, we will get 3 minus 2i in the numerator and 2 minus 2i in the denominator. But if you remember, we need mod fz, so let's take mod on both sides. So we will get mod 3 minus 2i and mod 2 minus 2i. In numerator, the real part is 3 and imaginary part is minus 2. So in numerator, we will get 3 square, which is 9, plus minus 2 square, which is 4. And in denominator, your real part is 2 and imaginary part is minus 2. So its mod will be under root of 4 plus 4. So we will get under root of 10 upon under root of 8, or we can say 10 upon 2 root 2, or we can say root 5 by 2. So we get our mod fz, but our answer should be in terms of mod z. So let's get mod z. Your real part of the z is 1 and imaginary part is 2. So we can say your mod z must be under root of 1 square plus 2 square, which is root 5. So instead of root 5, we can place mod z. So your answer must be mod z by 2, which is given in option A. Ta-da! In this question, we have to find x and y if your x plus iy is equal to 1 plus I cube upon 1 minus I cube minus 1 minus I cube upon 1 plus I cube, or we can say whole cube of 1 plus I upon 1 minus I minus the whole cube of 1 minus I upon 1 plus I. We can simplify 1 plus I upon 1 minus I as I. So we will get I cube, and in second term, this 1 minus I upon 1 plus I can be simplified as minus I. So we will get minus I cube. Now, we know the value of I cube is minus I. So here we'll get minus I, and minus minus become plus, I cube is minus I. So finally, x plus iy is simply minus I and minus I, or we can say minus 2y. Here we have 0 minus 2y. So compare the real part, we will get x equal to 0, and by comparing imaginary part, we will get y is equal to minus 2, which is given in option A. Ta-da! Here it is given that imaginary part of our complex number 2 plus I upon ai minus 1, or we can say minus 1 plus ai is 0. So we have to find the value of a, which is a real number. So to get the value of a, we have to simplify our complex number by multiplying conjugate of the denominator. So we have to multiply minus 1 minus ai. Now let's simplify our numerator. This 2 multiplied with I will give us minus 2. Then 2 into minus a will give us minus 2ai. Now it's time to multiply I with minus 1 will give us minus I, and I into minus a will give us minus ai square. In denominator we have minus 1 plus ai minus 1 minus ai, which will give us minus 1 square minus ai the whole square. In further simplification, this minus ai square will become a. So we will get a minus 2 as a real part. And this minus 2ai and minus I is your imaginary part. So let's take I common. We will get minus 2a minus 1. And in denominator, we have 1 plus a square. So let's give individual denominator of 1 plus a square. Now let's get the imaginary part of the z, which is minus 2a minus 1 upon 1 plus a square. And it is given that your imaginary part is 0. So let's write down is equal to 0. So finally we have 2a minus 1 is equal to 0, which will give us a is equal to minus 1 by 2, which is given in option C. Ta-da! Here we have to find the real value of alpha, for which your complex number 1 minus I sin alpha upon 1 plus 2i sin alpha is purely real number. That means the imaginary part of the z is 0. So let's find out imaginary part by converting our complex number into the standard form. And for that, we have to multiply and divide by conjugate of the denominator, which is 1 minus 2i sin alpha. So let's simplify. This 1 multiply with 1 will give us 1, and 1 into minus 2i sin alpha will be minus 2i sin alpha. Then minus sin alpha into 1 will give us minus I sin alpha, and minus I sin alpha and minus 2i sin alpha will give us 2i square sin alpha. In denominator, simply we have a plus b and a minus b, or we can say a square minus b square, which is 2i sin alpha the whole square. So it's time to get the real part. This 2i square sin alpha will become minus 2 sin alpha. So your real part will be 1 minus 2 sin alpha, and minus 2 sin alpha and minus I sin alpha will give us minus 3 sin alpha I, and in denominator we have 1 plus 4 sin square alpha. So let's give individual denominator of 1 plus 4 sin square alpha. Now it is given that the imaginary part of the z is 0. So let's get the imaginary part of the z, which is minus 3 sin alpha upon 1 plus 4 sin square alpha, and which is equal to 0. So denominator multiply with 0 will become 0, and we will get minus 3 sin alpha is equal to 0, or we can say sin alpha is equal to 0, which gives us alpha is equal to null set of sin alpha, which is n pi, which is given in option C. Ta-da! In this question, you have to find the real value of theta, for which your complex number 1 plus I cos theta upon 1 minus 2I cos theta is a real number. That means the imaginary part of our complex number should be 0. And for that, you have to get the standard form of that. So, let's multiply and divide by conjugate of the denominator, which is 1 plus 2I cos theta. Now let's simplify our numerator. 1 ones are 1. 1 2I cos theta will become 2 cos theta I. Then I cos theta ones are cos theta I. And I cos theta into 2I cos theta will give us 2 cos theta I square. And in denominator we have a minus b and a plus b. So we will get a square minus b square, which is 4I square cos square theta. So let's collect the real part. We have 1 and this 2 cos theta I square will become minus 2 cos theta. And 2 cos theta I and cos theta I will become 3 cos theta I. And in denominator we have 1 plus 4 cos square theta. So let's give it individual denominator of 1 plus 4 cos square theta. So we get our z in the standard form. Now it's time to compare our imaginary part, which is 3 cos theta upon 1 plus 4 cos square theta is equal to 0. Your denominator multiplied with 0 will become 0. So finally we will get 3 cos theta is equal to 0, or we can say cos theta is equal to 0. So here your theta must be null set of the cos theta, 2n pi plus or minus pi by 2, which is given in option C. Ta-da! Here your x is a real value, which satisfied our equation 3 minus 4ix upon 3 plus 4ix is equal to alpha minus beta I, if alpha square plus beta square is equal to one of the following option. That means we have to find alpha square plus beta square. So we can get it by taking mode on the both side. So let's take a mode to each complex number. So in numerator we will get under root of your real part, which is 3 square, plus imaginary part, which is minus 4x the whole square. And in denominator we will have under root of real part square, which is 3 square, plus imaginary part square, which is 4x the whole square. Similarly, on right hand side we have real part square, alpha square, plus imaginary part square, which is minus beta the whole square. So on left hand side we will get under root of 9 plus 16x square in numerator as well as in denominator. And on right hand side we will get under root of alpha square plus beta square. So under root of 9 plus 16x square will cancel out and we will get 1. So square both the side and you will get alpha square plus beta square is equal to 1, which is given in option A. Ta-da! In this question, we have to find modulus of 1 minus I upon 3 plus I plus 4I upon 5. And to get the modulus, we have to simplify our first term by multiply and divide by conjugate of the denominator. So it will be 3 minus I. So 1, 3s are 3. 1 minus I is a minus I. Then minus I into 3 will give us minus 3I. And minus I will give us plus I square. In denominator, we have a plus b and a minus b, which will give us a square minus b square plus 4I by 5 will be remain as it is. Your I square will become minus 1. So 3 and minus 1 will become 2. And this minus I and minus 3I will be minus 4I. And in denominator, we have 9 plus 1. Or we can say 10. Your 4I by 5 will remain as it is. In further simplification, you can take 2 common. So you will get 1 minus 2I upon 5 plus 4I by 5. Now here, your denominator is common. So the real part will be 1, and to get imaginary part, you have to take minus 2I plus 4I, or we can say 2I. Let's give individual denominator. So 1 by 5 plus 2 by 5I. So we can say the real part of the z is 1 by 5 and imaginary part of the z is 2 by 5. So we can easily get the mod z, which is under root of real part square plus imaginary part square. So here we'll get under root of 5 by 25, or we can say root 5 by 5, which is given in option C. Ta-da! In this question, you have to find z raised to 14, where your z is 7 minus I upon 3 minus 4I. So first of all, let's simplify our complex number by multiply and divide by conjugate of the denominator, which is 3 plus 4I. So in numerator, 7 3s are 21, 7 4i's are 28I, then minus I into 3 will give us minus 3I, and minus I into 4I will give us minus 4I square. And in denominator, we have a minus b and a plus b form, which will give us a square minus b square. Now let's collect the real part. 21 and this minus 4I square will become plus 4. So we will get 25. And this 28I and minus 3I will become plus 25I. And in denominator, we have 9 plus 16, or we can say 25. So your complex number is 1 plus I. But as you know, we need to find z raised to 14. So we can say z raised to 14 is 1 plus I raised to 14. Now, to get this, we have one technique. You have to take 1 plus I the whole square. So whole raised to 7. Now, if we expand 1 plus I, we will get 1 square plus 2 times I plus I square, whole raised to 7. Now we know that your I square is simply minus 1. So I square and 1 will cancel out, and we will get 2I raised to 7, or we can say 2 raised to 7 and I raised to 7. Now I raised to 7 can be rewrite as I raised to 4 into I cube. And we know that your I raised to 4 is simply 1 and your I cube is minus I. So here you will get z raised to 14 is equal to 2 raised to 7 into minus I, or we can say minus 2 raised to 7 into I, which is given in option D. Ta-da! Here it is given that root of minus 7 and minus 24i is x minus iy. So if we find out the root of the left hand side by comparing real part and imaginary part, we can get x and y. But actually we have to find out x square plus y square. So to get the x square plus y square, let's take mode on both sides. So we will get mode of minus 7 and minus 24i raised to 1 by 2 is equal to mode of x minus yi. Now to avoid the under root, let's square both the sides. So we will get mode of 7 minus 24i will be equal to mode of x minus yi the whole square. On left hand side, the real part is minus 7 and imaginary part is minus 24. So we can say its mode is under root of minus 7 the whole square plus minus 24 the whole square. And on right hand side, the real part is x and imaginary part is minus y. So due to the square, we don't have to take root. We will get x square plus y square. So we can say your x square plus y square is simply 25, which is given in option B. Ta-da! In this question, we have to find under root of minus 8 and minus 6i. So the complex number is minus 8 and minus 6i. Its real part is minus 8 and its imaginary part is minus 6. Here, your imaginary part is less than 0. So we have to select the second formula. And for that, we need mod z, which will be under root of real part square plus imaginary part square, or we can say it will be 10. So let's use the second formula of roots of z, which is plus or minus under root of your z, which is 10, plus your real part, which is minus 8 divided by 2, minus I of under root of your mod z, which is 10, and minus your real part, which is minus 8 divided by 2. So we can say we will get plus or minus 10 minus 8 will be 2 and 2 by 2 will be 1. So here we'll get 1 minus I of 18 by 2, or we can say root of 9, which will give us 3. So ta-da! This is your final answer, which is given in option B. In this question, it is given that under root of x plus iy is equal to plus or minus a plus ib, and we have to find under root of minus x minus iy. Now, if we take minus common, we will get x plus iy, and give individual denominator, you will get under root of I and under root of x plus iy. Now we know that under root of minus 1 is simply I, and under root of x plus iy is given in the question as a plus or minus a plus ib. Now to simplify, let's multiply I with a, will give us plus or minus ai, and I with b will give us bi square, or we can say plus or minus ai minus b, which is not given in the option. So correct answer is option D. Ta-da! In this question, we have to find square root of our complex number 3 minus 4i, where your real part is 3 and imaginary part is minus 4. So, to get the root, first of all, we have to find out mod z, which is under root of real part square plus imaginary part square, will give us 5. Now, your b, or we can say imaginary part, is less than 0. So, we have to use second formula. So, we can say our roots of z is plus or minus under root of mod z, which is 5, plus real part, which is 3, divided by 2, minus I under root of mod z minus real part by 2. So here we'll get plus or minus 5 plus 3, or we can say 8 by 2 will give us root 4, which is 2, minus I times 1. So plus or minus 2 minus I is your final answer, which is given in option B. Ta-da! In this question, you have to find value of mod z minus 5, where your z is x plus iy. So let's try to get mod z minus 5. First of all, substitute the value of z, which is x plus iy minus 5. Now, to get the mod, we have to get real part and imaginary part. So, here x and minus 5 are the real part. And from the iy, we can say your imaginary part is y. So, let's write down a is equal to x minus 5 and b is equal to y. So, its mode is simply under root of real part square plus imaginary part square, which is given in option A. Ta-da! Here we have to find the value of z, which satisfies our condition, which is mod of z plus I should be equal to mod of z minus I. Now, let's assume our complex number z is equal to x plus iy and substitute in our condition. So, we will get x plus iy plus I and x plus iy minus I. Now, let's try to collect real part as well as imaginary part. Your x will be as it is and take I common from the last two terms, will give us y plus 1. Similarly, on the right hand side, x will be as it is and take I common from the last two terms, will give us y minus 1. So, on left hand side, the real part is x and imaginary part is y plus 1. To avoid the under root, let's square both the sides. So, on left hand side, we will get x square plus y plus 1 the whole square. And on right hand side, the real part is x and imaginary part is y minus 1. So, we will get x square plus y minus 1 the whole square. Now, your x square will cancel out, and if we expand y plus 1 the whole square, we will get y square plus 2y plus 1. Similarly, on right hand side, we will get y square minus 2y plus 1. Here your y square and 1 will cancel out, and this 2y plus 2y will give us 4y is equal to 0. And we can say your y is 0. Now, if you remember, we have to find the value of z, and we assume that your z is x plus iy. So we can say your complex number will be equal to x plus I0, or we can say your imaginary part is 0. So your complex number can be any real number. Ta-da! In this question, we have to find solution of our equation mod of z minus z is equal to 1 plus 2y. Basically, we have to find out the complex number z which satisfied this number. So let's assume z is equal to x plus iy. But we also need mod z. So we can say mod z is simply under root of x square plus y square. Now let's substitute the values. Your mod z is simply under root of x square plus y square, and your minus z is minus x minus iy is equal to 1 plus 2y. Now, to get the value of x and y, let's compare real part of the both sides. On left hand side, your real part is under root of x square plus y square minus x should be equal to real part of the right hand side, which is 1. And if you compare imaginary part of the both sides, then we have minus y on the left hand side and plus 2 on the right hand side, which will give us y is equal to 2. Now just substitute the value of y in equation number 1. You will get under root of x square plus 4, and if you take minus x on the right hand side, you will get 1 plus x. Now to remove this under root, let's square both the sides. So we'll get x square plus 4 is equal to 1 square plus 2x plus x square. So here your x square will cancel out, and we will get x is equal to 3 by 2. And if you remember the question, we have to find the complex number z, which we assume as x plus iy. So let's substitute the value of x, which we find out as 3 by 2 plus I times your y, which is 2. So your complex number is 3 by 2 plus 2y, which is given in option B. Ta-da! Hope you enjoy the video. Keep practicing and get the full marks. Bye-bye.